Today I'm going to be showing you how to solve question 9 of the 1995 College Board AP Free Response section of the AP test. There are 4 parts in this section, and although there is not a lot of math involved, it involves understanding concepts of the kinetics topic. 2 reactions are given at the beginning of the problem, the first one being A2 plus B2 yields 2AB. The second reaction is X2 plus Y2 yields 2XY. The problem states that 2 reactions are represented above. The potential energy diagram for reaction 1 is shown below. The potential energy of the reactants in reaction 2 is also indicated on the diagram. Reaction 2 is endothermic, and the activation energy of reaction 1 is greater than that of reaction 2. The diagram given looks like this. The reactants A2 plus B2 are higher in energy than the products 2AB, so that means that reaction 1 is exothermic. They give us the reactions of reaction 2, X2 plus Y2. Part A states, to complete the potential energy diagram for reaction 2 on the graph above, it says that reaction 2 is endothermic and that its activation energy is lower than reaction 1. So it'll be drawn like this. The activation energy will come up, but it will be lower than the first part, and it'll level off above the reactants because it is endothermic. And you'll see that H is going to be positive, and the activation energy will be labeled here. After you finish your diagram, you have to label the products 2XY. And now your diagram is complete and part A is done. So on your test, your answer will look close to this. Go on to part B. Part B says, for reaction 1, predict how each of the following is affected as the temperature is increased by 20 degrees. Explain the basis for each prediction. Part 1, rate of reaction. The rate of reaction is going to increase with an increase in temperature. Because of the increase in temperature, there is an increase in kinetic energy, meaning that molecules will move faster and collide with each other more often, and more molecules can overcome the required activation energy, speeding up the rate of the reaction. This overall increase in energy due to the increase in temperature will overall speed up the reaction. For part 2, it asks how the heat of reaction would be affected. Since 20 degrees is such a small number, the heat of reaction will not be greatly affected, if at all. So all we need to know is that the heat of reaction will barely change, if at all, due to the small temperature increase. Part C. For part C, it says, for reaction 2, the form of the rate law is rate equals kx2 raised to the m times y2 raised to the n. Briefly describe an experiment that can be conducted in order to determine the values of m and n in the rate law for the reaction. To have a more visual picture, I'm going to draw a table so we can fill in values to show how the rate can be found for reaction 2. The table will look something like this. You draw your table and have a column for time, concentration of X2, concentration of Y2, concentration of your product XY, and your rate. And you're going to want to have 3 experiments set up. Okay. Now let's say that in the first experiment you have 1 mole of X2, 1 mole of Y2, and it produces 2 moles of your product XY. For the second experiment, we'll have 1 mole of X2, 2 moles of Y2, and 4 moles of your product. Lastly, for experiment 3, you'll have 2 moles of X2, 2 moles of Y2, and 16 moles of your product. And for each experiment, we'll just assume each only take 1 second to make the time easier, to make the math easier. We can see that in the table that I made sure to have had X held constant between reactions 1 and 2 and varied Y, and for reactions 2 and 3, Y was held constant while X was varied. This set up our experiment perfectly so we could determine the rate law. The equation to find rate for each experiment is rate equals change in product over change in T, which is time. You have 0 moles of product to begin with, and a certain amount of product after the reaction is complete. The change in product will equal the numbers in our table for these experiments. For reaction 1, 2 divided by 1 equals 2, so the rate will be 2. For reaction 2, 4 divided by 1 equals 4, so the rate will be 4. For reaction 3, 16 divided by 1 equals 16, so the rate will be 16. To find the order of the reaction, we will need to solve for m and n in the rate law. When we compare experiments 1 and 2, x is held constant, so we can ignore it. We see that y is doubling and the rate also doubles, so we can set them equal. Since y is doubling, the equation is 2 to the n equals 2, since the rate is also being doubled. So what makes this equation true? When n equals 1. So we can see that this reaction is first order. When comparing reactions 2 and 3, we see that x is doubling while y is being held constant. This time, the rate is being quadrupled. So the equation is going to be 2 to the m equals 4. What makes this equation true? 2. So m must equal 2. So this means that this reaction is going to be second order. So now we have figured out x is second order while y is first order. So now we have found m and have fulfilled the requirements of part C. Our last part D says, from the information given, determine which reaction initially proceeds at a faster rate under the same conditions of concentration and temperature. Justify your answer. From the graph we drew, we can see that reaction 2 is the answer. Because it has a lower activation energy, it is going to proceed at a faster rate than that of reaction 1. More molecules can overcome the activation energy at this lower energy and can therefore proceed faster. This completes question 9 of 1995 College Board AP Chemistry Free Response section. Thank you for listening.